Okay, so I'm in the lab today and we are going to do experiment one. And experiment one is chemical and physical properties. All right, so we're gonna, there's like 5 or 6 parts to this particular lab. So they're gonna go over physical and chemical properties as well as physical and chemical changes. So let's just be very clear on the front of it is if it's a physical property, you're trying to describe something, so it's descriptive. So you can have melting point, boiling point, color of a substance, that kind of stuff, you know. If it's a chemical property, you're thinking about does it react with acid? Does it react with base? Is it flammable? So can you set it on fire? All right. So these are like, is it corrosive? Is it toxic? Those kinds of things. Those would be the chemical properties. All right. So physical change versus chemical change. A physical change is when you have a change of state. So that means the identity of the substance will not change. So if I was to stick a ice cube down on the bench top and it melts, it goes from the solid phase to the liquid phase. And so because that is a change of state, that is a physical change. All right, and by change of state, I mean it went from a solid to a liquid, and it did not change the identity of the substance. The substance is still water. All right, so whether it's in the form of a solid or whether it's in the form of a liquid, it is still the same substance. Okay, so that is physical change. Now, a chemical change is when you actually break bonds and you make a new substance. All right, and so a lot of times when you have a chemical change, you see bubbles, you see color change, you see something happening. All right, and so that is an indication of a chemical change. And again, you're breaking bonds and you're forming something new. All right. All right, so if you look at your lab, it says part A, and this one is all kind of, you're just kind of doing it in your head because we are not allowed food in the lab. All right, so part A says cookie versus cracker. So just think about your favorite cracker. My favorite cracker is a club cracker. So I'm thinking about a club cracker, okay? And so the first part of it, they want you to, if you were to crush this cracker into like small pieces, all right? Would it be difference in color, smell, or taste between the small pieces versus the whole? And then when you are crushing it and you're breaking up into little pieces, would that be a physical change or would that be a chemical change? So that's what you would reference on your lab report sheet. All right, and then you would do the exact same thing for a cookie. So like for me, I would take a like chocolate chip cookie. All right, and so I would think about that chocolate chip cookie, I would describe it, so that would be physical properties. And then if I crush up that chocolate chip cookie, is it going to be any different when I crush it up than when it is whole? Is it going to still taste the same? It's just going to be in like pieces or whatnot. And again, would that be a physical or would that be a chemical change? So that is the first, or part A. And again, you're just thinking of it. Now you're at home, so you can take a cracker and you can take a cookie and you can actually do that. Okay, so that is part A. Now part B, they would like you to take a little bit of sodium chloride. Okay, so I just have sodium chloride right here. Okay, and then they want you to put a small amount on a piece of weighing paper. So here we have weigh paper. Okay. And I'm just going to pour a little bit of sodium chloride on that weigh paper here. Okay, so I'm just going to put it so that you can so that you can see that a little bit. Sorry for the little bit of technical difficulties here. Okay, so I have that salt right there. All right, and this is just table salt, so you have this at your house as well. Okay, so I just put a few pieces of salt on this weigh paper, and then it says they want you to describe the flavor. A lot of people say it's salty. That's what a lot of people say. You're going to record that results on your data page. And then they want you to put about 5 mils of water in a test tube and then add this small amount of sodium chloride to it, and then try and get it to dissolve. Okay? Now, because I am starting to do some lab work here, I'm going to change out of my glasses and I'm going to put my goggles on, okay, so that I am completely safe. All right, so what we have here is a test tube rack. So this is where you're going to put your test tube. So I'm going to put a test tube right inside of here, okay, and then what I am going to be doing here, okay, using my test tube rack, is I'm going to be adding water, okay, so I'm just adding water. Okay, so it says about 5 mils or so. I'm going to add water, and then I'm going to add a small pea-size amount of that salt right in there into that test tube that we have right here. Okay, you'll notice how it immediately just goes to the bottom. Okay. So I'm going to get a glass stirring rod out. And it tells me to use my glass stirring rod, okay, and try and get all of that to dissolve. Okay, so I'm just going to be here and use my glass stirring rod until it all dissolves. Oh. Okay, it is all dissolved now. So I'm going to put it back in my test tube rack. All right. Okay. So now you've created a salt solution. Okay. If you were to taste it, how would it taste? Then would it taste any different, the salt solution, from just the salt itself on the piece of whey paper? And then when I dissolved it in the water, when it's dissolved in this particular water, is it a chemical or is it a physical change? Okay. Right, so the next thing that we need to do is that it tells us is to set up the Bunsen burner. So you guys have not been in the lab before, so here's your base. It's all found underneath your sink, and you will get your ring stand set up. So you just screw this in to the bottom here. Okay, so we'll have this ring stand set up now, and then you will use an O-ring. Okay. And I'm just going to put it like yay high. Okay. And then they want us to heat part of this solution. And so some people go ahead and just put that watch glass. This is a watch glass. All right. And they just put it right there on that O-ring. All right. So that is not good to have glass against metal. So you always use what you call wire gauze. And you take that wire gauze and you just stick it right on top of that O-ring. And then you put that watch glass right there. Okay. Alright, so now we need to, this is a Bunsen burner, okay, so it's got a tube and it's going to get hooked up to the gas line right here, but there's really only 3 ways or 2 ways that you can operate this. You can turn on the gas by the valve right here, and then what you can do is you can fluctuate right here, alright, and if you want a weak flame, you want to make sure that these valves are fairly closed. If you want a strong, like that cone, then you want to open it up as hot as possible. So that is, we do want a hot flame, so we want it slightly closed. And when it's closed like this is the best way to light it. All right. So sometimes when you light it, sometimes Bunsen burners are hard to light, and that's if that valve is open too much, then it's harder to light. So you want to make sure that you have it closed, and then that'll make it easier for you to light your Bunsen burner. Okay, so I have it set up, and so this is what it looks like. So there's the valve. It's the blue knob that has the gas on it. Okay. And then here is my setup, right like that. Okay. So you can see my Bunsen burner. And I have it slightly closed right here. So I'm going to use a striker in order to light this Bunsen burner right now. Okay. So that's the game plan. I'll put this back on the stand right here so that you can see it and you can see what I'm doing. Okay. So let me get a striker out. I'm going to turn on the gas, and here's your striker, and you got to push down on it so that it has a spark. Okay, I'm going to turn on the gas. You can hear it. Okay, and we're just going to go like that. And now we have our Bunsen burner, and you can control the height with this particular one based on your valve. Okay, so it tells us to put a little bit of the solution right on this watch glass. So I just put a small amount of it on there. And when you're heating a watch glass, you want to make sure that you don't heat it in one spot. Okay, so that's why you pick up the Bunsen burner. So you'll notice that I'm holding it and I'm going back and forth. All right, and I'm doing that so that I can heat up that water. And then I'm going to, because I'm heating it, the water then is going to evaporate. And I'm just holding it back and forth, like so. Okay, so I can see bubbles happening. So that means that so the water is going from the liquid phase to the gaseous phase. So I'm just going to wait until now it's sizzling. Okay. Okay, so when this water evaporates, what should I have left? Okay, the water level is getting smaller and smaller because it's evaporating, and so I'm seeing the evidence of some white solid forming. Okay, it is popping a little bit as it's drying. Okay, let me get you from the different let's see if I can. Okay, so maybe I'm not a camera person. Okay, so you can see what's going on. Alrighty, so now that one has gone to dryness, and let me just show you that. Okay, and where is it? There it is. Okay, so I have a white residue right left on that watch glass. Okay, so that is part B, and they want to know now whether that is a chemical or that is a physical change. Okay? Okay. Okay, part C said they want you to take a small amount of sugar and put it on a clean, dry watch glass. So remember, this is a watch glass. So it's clean and dry, and so I'm going to put, as you can see, I'm just going to put a little bit of sugar. So this is just common sugar that you would have at your house. Okay. Oops. You don't need that big black one, so we'll just go like that. Okay, so just a small amount of sugar. Okay. And then they want you to imagine what it tastes like. Okay, again, you're not putting anything in the lab in your mouth. Okay, and so I've just put it right where I had my part A of the experiment. Okay. And I'm going to, they want me to heat it, all right, and they want me to light the Bunsen burner and heat the sugar, and they want me to heat it until it forms a liquid, okay? So they want me to do that, and they want me to stop before it turns brown. So this one's always hard for me to do, honestly, because sugar is so easy to go from the solid state to the liquid state, and then it starts burning, all right? So I'm doing what I did before. I've got a watch glass, I've got sugar on the watch glass, and I'm heating it. And again, I'm not leaving the Bunsen burner straight down so it gets hot in one spot, because I don't want to break that watch glass. So I'm going back and forth until I can heat up that sugar. All right, so let me give you that aerial view. Hard to do because with my left hand sometimes. Okay, so here is your aerial view of it. Okay, so I am heating that sugar up, so you can see that white solid. It is still a white solid at this time. Okay, so I'm going to try to heat it, and I'm going to try and get it to go to where it's just a liquid. Again, sometimes I have trouble and it goes to where it's light brown. We will see. Okay, so I'm going to lift you up again, okay, and you can tell that I have got it to the liquid phase, okay, and so that is part C. Okay. So I'm going from the solid state to the liquid state of the sugar. So I stopped it just in the nick of time to where it was a liquid. All right, so I'm going to take it, I'm going to wash that off. Put it in the sink first to let it cool down. Okay, so that is part C. I'm just going to push that out of the way. All right, so now going from a solid to a liquid for the sugar, they want you to comment on, is that a chemical or physical change? So it was just liquefied. Okay, so it didn't turn brown. So you can make your decision. All right, so part D is all about paper. So we have a piece of filter paper right here. And so what I'm going to do is, there's two parts of this. They want you to take a piece of filter paper and they want you to tear it, all right? And they want you to tear it in small little pieces. So that's what I'm going to do, okay? So that's the first part of this one. So all I did was took that piece of paper, and as you can tell here, is I have just have it in pieces, all right? Have you changed the molecular composition of the paper by ripping it up, all right? And then on your data sheet, comment, because I ripped it up, did I change the composition of it? okay? And then by ripping it, did I, dun, 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 is it a chemical or physical change? Okay. Alrighty. Now, the other half of the filter paper that they want you to take is they want you to take a piece of filter paper, and then they wanted you to put sulfuric acid on it. Alright? Okay? And so when I put sulfuric acid on it, then this is what it looks like. Okay? Okay? So you can see that it's eating away the paper. Okay? And eventually it's going to form holes where those spots are. So I tried to make a smiley face. But it is going to form holes. So it's eating away the paper. Okay? And so now I need you to comment for part D on is that a chemical or physical or chemical change. Okay. I spilled a little bit of acid, so I'm just going to clean that up real quick. Alright. Okay, so that is part D. Alright, so part E and F, so we have 2 parts left. And out of part E, it says that they want you to take baking soda, okay? And then they want you to take vinegar, okay? Okay, so I think most of you know what baking soda is because you have it like in an Arm & Hammer bottle or a Meyer container, you know. If you have it at your house, okay? So first thing is they tell you take a small amount baking soda and put it into the 50 ml beaker. Alright, so they want me to take a little bit of baking soda. So that's what I'm going to do, and I'm going to put a little bit of baking soda in there. Oh, and I spilled it. Okay, so I've got baking soda. And then they want me to take that baking soda they want me to put, let me have you see it. They want me to put a dropper full in there. Can you hear it? And what do you see? Okay, so I'm taking vinegar. And I'm putting it in that baking soda. Alright? Okay, so comment on what you observe. And then I have used up all the baking soda that's inside that. I think I have. Let me double check. Let me add more. I have not. You see how? Because I have a lot in there actually. Okay. And so it tells you to add until you've used all of that baking soda. Okay. So those bubbles are going to be formed because that's CO2 coming out. Okay. And so that is what you call taking baking soda and hitting it with vinegar. And so now you need to comment on whether that is a chemical or is it a chemical or physical change? Physical or chemical change. That's what you need to decide. Okay? So we're ready to do the last part, right? And so the last part is we're going to take a beaker, and it says take a small amount of potassium chloride. So So you always read your labels to make sure you choose the right chemical. And it says dissolve a small amount in a small beaker. Alright, so I'm just going to take a little bit of it and put that in there. And it says to dissolve it in water. So I'm just going to use my deionized water squirt bottle here. Okay. And you'll notice just by squirting in water that all of it has dissolved. Okay. So there's no solid left in there. It has all dissolved in there. So I put some potassium chloride, okay, and I stuck it inside the beaker, and then I added water to it, and you will notice that it all dissolves. So what can you say about that is that potassium chloride is very soluble. Okay? So now what they want me to do, okay, is take a dropper full or 1 drop of silver nitrate, and they want me to add it to it. So I'm going to let you watch that. Okay, so when I add it, do you see something forming? Okay, so you see a solid forming. Okay, and that is your solid that is forming. Now that solid cannot be potassium chloride because potassium chloride is very soluble in water. Okay, so this is a new substance. All right, so when I take potassium chloride and I add silver nitrate to it, then what happens is a solid forms, all right? And when a solid forms, we call that a precipitate, right? So that precipitate has formed. Now it tells you in your lab that that precipitate is silver chloride. And so you can see that solid if I tilt that beaker up like that. Okay? So this new solid does not dissolve very well. Okay? It does not dissolve very well. So what they want me to do now, we want to test the solubility of the silver chloride, all right? And so they want me to heat this mixture gently, all right? And to see if by heating this silver chloride, that's my precipitate that I just formed, will that silver chloride dissolve? All right, and what's the thought process behind that? I think you all realize that when you heat water up, more things dissolve in it, correct? So when you increase the temperature of the water, substances dissolve more. So you can get more salt to dissolve, you can get more sugars to dissolve, that kind of stuff. So if I take this silver chloride and it doesn't look like it's very soluble right now, and if I heat up the water, will it make the solubility of that silver chloride more soluble? So will it go into that solution and make it soluble? So that's why they want me to heat that water up and to see if it will dissolve with that added heat to it. All right? Okay, so, and that's what they want you to do, is to comment on the solubility properties. Okay, so we talked about what is soluble, what is not, that kind of stuff. And then they want you to comment on, when I mix these two items together, the potassium chloride and the silver nitrate, I formed silver chloride, so I formed something new. And so would that be a physical change or would that be a chemical change? Okay, so I'm going to move this real quickly. Okay, and I'm going to set up my Bunsen burner again. Okay, I'm going to put this right up here, and I'm going to heat this. And I'm going to see if that, by heating it, is going to make it more soluble, and will that silver chloride dissolve when I heat it. Okay, so that is the goal. Okay. As of right now, I'm going to go with no, it's not very soluble. I still see the solid, and it is not dissolving. I'm going to wait for the solution to get a little bit hotter. But I don't want it to boil, like I don't want the water to boil. Okay? Okay. And so what I'm noticing is the water is about to boil here, and It's about to boil. It's slightly boiling. And even with probably the worst camera person in the world here. Okay, so even with the water slightly boiling right there, I do not see a difference in solubility. So I want to show you what it looks like. The water was slightly boiling, and here's my precipitate, and I have just as much precipitate as I did before. So the silver chloride is not very soluble in water, even when I heat up the water to boiling. Okay? So that's experiment 1, chemical and physical properties.